With broad experience of more than 15 years, GISA carries out engineering and architectural design services with a very high added value for our clients. GISA activity is developed in different sectors: industry, civil engineering, the military, commercial, public, residential. Among others, GISA provides services of 3D laser scanning and BIM. BIM, an acronym for Building Information Modelling, is a collaborative working methodology which combines all the different agents taking part in the process of construction throughout its whole life cycle. The main goal of BIM methods is to generate a virtual model of the building containing all the information related to the construction and the facilities of the building itself in a technical as well as a geometrical level. The basis of the production of a precise BIM model in existing constructions is the realization of point clouds through the laser 3D scanner technology in what could be called SCAN to BIM process. Thanks to this technology, geometrical data and the colors of the different locations and objects are registered by these point clouds, as well as their GPS positions. The combination of different point clouds in the same representation system defines digitally, in a very precise and reliable way, the locations and objects captured by the laser 3D scanner. Through storage platforms on the cloud, it is possible to manage and visualize the scenes and point clouds captured by the scanner, find their locations, as well as measuring distances and areas, and to even take notes. Generated point clouds are processed to be subsequently inserted in modeling BIM software, making a reliable model for the future. The amount of information related to the BIM models is classified through different levels of development called LODs. Depending on the purpose of the mentioned model, it will be necessary to reach one higher level of development or another. By combining point clouds and original drawings of the building project, it is possible to carry out a basic model of architecture, achieving a LOD 200 level of development. Once the building is scanned and its model has been made, taking the point clouds as its basis, a process to model the facilities of the different disciplines that can be integrated into the BIM model begins. Among these disciplines we can find HVAC systems, water supply and sanitary sewer, fire protection, lighting, electrical power circuits, and telecommunications, among others. Since we have all the facilities modeled in BIM, we can obtain as-built drawings and documents of the building in a reliable and precise way. Also, because we have all the information in a single model, any modification that may be made, which would affect the different disciplines, for example, a change to any architectonic level, would be updated automatically in any of the other disciplines affected. The modeled elements may appear simple objects that are drawn three-dimensionally, but their behavior is as complex as its function and type requires. Therefore, in a duct system, the typology of the ducts is identified, along with its fittings, the flow direction of the system it belongs to, in order to make the supervision of the installations possible by a BIM modeling software system. This method makes even possible the detection of clash and conflicts with other disciplines, an essential task to reach the level of development LOD 350. Apart from the information inherent to the modeled elements, it is possible to add all the information and documents that could be necessary for its proper definition, such as fact sheets of devices, manufacturer data, manuals, technical instructions, pictures, etc. Thanks to all this information, the level of development LOD 400 can be achieved, what could be also called construction level, containing the necessary amount of details to accomplish construction and installations. If needed, through the cloud-based platforms, it is possible to have remote access to all the information included in the model, from any PC or mobile device. This is highly useful in tasks such as quality control manager, site manager, and facility manager, among others. So, thanks to the SCAN to BIM process, in connection with the use of BIM methodology, we're able to generate a virtual, precise, and reliable model of the building and its facilities, by means of which we can design and coordinate projects for new facilities and renovations, perform site survey on existing projects, and develop as-built documentation, schedule the preventive and corrective maintenance tasks, optimize space, perform clash detection, among many other applications. Apart from SCAN to BIM process, the 3D laser scanner technology can be applied to other situations such as industry, topography, civil construction, dimensional analysis, volume calculations, reverse engineering, shipbuilding and aerospace manufacturing, criminology, heritage and archaeology. GISA, working on sustainable engineering since 2003.